Hi everyone, welcome to CodeTav Management. So today we will discuss the valid anagram problem. So first of all, see the question. Given two strings S and T, return true if the two strings are anagrams of each other. Otherwise, you need to return false. So first of all, you need to know what is anagram. So two strings can be anagram when in both strings same characters will be there. Okay, whatever characters will be in first string, those same characters will be in the second string, and frequency of both will be also same. Okay, right? Okay, so suppose is equals to cat and t. This is suppose tech. In small case only I am going to write. Okay, so here the characters of the string is c a t. Here also t a c means all the characters also same and length also same, like frequency also same. Okay, if in both string frequency of each character will be same, then we can say the length of the characters, or the length of the string for both the string is same, right? So what will be the brute force approach? So brute force approach will be like every single character present in S, we need to check all are present in T or not, right? See, first I will check with this one, then with the second one, then with the next one, right? In the same way, the other members we also have to check. So every single character present in S, we need to check all are present in T or not. So here the what is the complexity, time complexity of it? It will be big of n square, which is not bad, good, right? It's totally bad. So what can be our good or optimal approach? So our optimal approach can be like, first of all, we need to check the length of each string is same or not. So s length of s and length of t should be same. That first check we will do. If that will be okay, then we will proceed further. Otherwise, we will return false as those strings are not anagram if the length will be different. Then second, what we will check? The frequency of any particular character is same or not. So suppose S. For the S string, the characters, the word is like CART. Suppose. Okay. So for T, this is suppose TARC. Okay. So here, if we will calculate the frequency of C, that is 1, for A, that is 1, for R, that is 1, for T, that is also 1. For the next string T, here also, if you will check the frequency of each character, then the frequency of T is 1, of A is also 1, of R, this is also 1, and for C, that is also 1, right? So to do this, if we will think, then in our mind, there can be two data structures. One is array and another is hash map. Okay, so we can take an array here. Why the array can be taken here? I will tell you why we can take the array here. Because here the concepts are for the alphabets, English alphabets, right? And as you know that for English alphabet there are how many characters? Total 26 alphabets are there in English. Okay, total 16 alphabets are there, right? So if you will think in that way, that suppose this is one array, so that is zeroth index, then first index, then second index. In that way, that is our 26th index, right? So if you will think in that way, and if we will keep according to that index, then A should be here, then B, then C, and at last the Z will be here, correct? Then we will calculate the count of each particular character for one string. Okay, then we will proceed. Suppose C, suppose this is one array. So first word, like first for the first string, the word has been given as the cart. Okay, so I'm assuming suppose A is there. If you will do the sequence in that way, then A C R T. So suppose A is in that place, C is in that place, in that way, R is suppose in that place, and T is suppose in that place. Okay, just assume in that way. Okay, now what we will do for the first string, if for the like we will proceed from the initial character, and initially the count of each character is 0 in this array. So what we will do for the first string, whenever we will find any particular character, then for this particular positions, we will calculate the count of it. So for the first one, suppose C, we've found this C, right? So what we will do for this is we will increment 1. And for T, whenever I will get it, we will just decrement it. Okay. Then if all the frequency will be same, then all over in the mm, count will become 0 again. So then we will check that the counts of those are 0 or not. So if the count will be not 0, then we actually return the false, otherwise we can return the true. Understood the story, right? So in that way we will proceed. So C, here the CART, the first character is C. Okay, for string S, again I am writing here CART, that is from the A string, and for the T string, that is TARC. So C, so here we got the C first. So suppose so initially the all are suppose 0 count, not suppose, the count are 0, right? In that way. So when I got this C, then I will increment 1, so it will be plus 1, right? Now go to A, or otherwise we can do in that way, this one by one anyway. So suppose see the character of this one also. Okay, so for T, the first character is T. So here I will decrement it. Okay, so it will be -1. Then go to the next. Because in one loop only we will increment for the first string and decrement for the second string. Now for the second character, this is A. So for A, again I will increment 1. Now for the T string, now the second character is also A. I will decrement it, well, like +1 then -1. Okay, so I will apply -1, then it will become 0 again. Okay, now the third one is R. So R, again I will increment it. So I have incremented it. Next here for T, that is also R. So here again I will decrement. So +1 -1, it will become 0 again. Now For the A string, the next character is T. So uh, for the T, it is -1. So now I will increment it. So -1 plus 1, it will become 0 again. And now for C, the C I have incremented when I got it in the A string. Now I will decrement it as I got it in the T string. So +1 -1, it will become 0 again. So if we will analyze the complexity, so see, for time complexity, for the time complexity, actually, in times of like for particular in, like for in number of characters, we are just doing these calculations and all, right? So the that complexity will be order of big N, where n is the size of S or T, right? And for the space complexity is big of 1. Why 1? Because we have used one static array, right? 26 alphabets. We and after that, the size of the array is not incrementing or decrementing, right? During this process. So this is the constant one. So 26 we have already taken as constant one. Let's discuss the code. So here the is anagram method, that is boolean type, as we need to return true or false. So first of all, as per our discussion, we are checking the length of two strings. So if we will get that the length of two strings are different, then simply we will return the false. Okay, and then we just initiated one array of the constant length, that is 26, and then we are iterating, okay, from 0 to the length of the array. Okay, then for the first one, whenever I will get it for the A string, I will doing the incrementing, and for the T string, if I will get any character, then I will decrementing. Okay, next what I will do, then I will check the count of each characters. Okay, if the count will be not 0, for the array, if any characters count is not 0, then we will simply return false, and if it will not, then we will simply return true. So let's submit it. Okay, so yeah, all test cases passed. Okay, so that's all. And here, if you will analyze the complexity, here you also can check. See, the time complexity is big O of n, space complexity of big O of 1. Why? The n is the length of the input string s and t, which are equal, and character counts, a fixed size array of 26 integers we have used. So that's why the space complexity is big O of 1. So that's all. Okay. So if you have any questions, you can comment down, and otherwise we will proceed further in the next question. Okay. So do like, share, and subscribe. That will motivate me. Thank you, everyone.